Now, if you notice, you have been um, using metals, non-metals, and all that, naming substances, and there's one particular element that you haven't touched yet, or we haven't fully focused on, and that element is the hydrogen element. Why do we keep it aside, right, before moving here? Because we said hydrogen itself, right, has um two characters, right? It has two characters. It's not straight. Sometimes it is acting as over here. It's in the middle here because it can act as meta type one, or it can act as group one element, or also belong to group seven element based on the situation that comes, right? So now we kept it aside so that we can focus after we know how to name the basic substances. Now we can talk about hydrogen now, which is why we are here. Okay, so this is what you have to know. If hydrogen is in a binary bond, is in a binary bond with metals. If hydrogen is in a bond with a metal, right, it's going to act as an anion because metals give out electrons. So at the other end, there should be someone that should receive it. And hydrogen has two characters. It can receive and it can give. So if hydrogen is meeting metals, right, it acts as a receiver or it acts as an anion. So hydrogen, when it is in a bond with any of the metals, right, it becomes the anion guy. When this hydrogen is in bond with the non-metal, it acts as the um, cation guy. That's his behavior, right? If you have a binary bond and then you are seeing hydrogen and you are seeing metals, so hydrogen and metal, right? That hydrogen is going to act as a metal. Let me illustrate that with a few examples that I have. For example, if I have sodium hydride, like sodium and then hydrogen, right? So this is the non-metal part. So actually sodium is Na plus and then H is H minus. These are the two that combine to form this. In this particular compound, hydrogen is acting as an anion. If you have another example, something like HCl. So chlorine, we know that chlorine is a minus, always minus. So hydrogen, if hydrogen combined with Cl minus, you need to take the other behavior, which is because the cation meeting an ion, right? That's what happened to hydrogen. So hydrogen, when hydrogen is in a particular bond, especially in a bond with the non-metals, right? It acts as the positive, and in a bond with the anion, it acts as a negative. Now, this is what you have to know. Um, Hydrogen actually in sense, right, in a sense, doesn't really lose its electron. It doesn't really lose its electron. It's yeah, of course, it's want to attain stability. But what's happening is that when hydrogen is meeting non-metals, right, it actually shares that electron with them, right? So hydrogen bonding with a non-metal is actually a covalent bond. It's actually a covalent bond. That's what it does. When it is meeting with a metal, that's ionic bond because hydrogen always wants to receive. So Na plus, we know sodium always give out one electron. Hydrogen is here, receives it, and becomes H minus. Now, when hydrogen is meeting chlorine, what happens? Hydrogen who has one atom, right? And then these guys also need one. So what happens is that this one electron, they will rather share it together. They rather share it together. So, but then when we are writing the compound, take it as if hydrogen is a metal and then chlorine is a non-metal. Basically, that's what I meant. Okay, so in a bond with when we are writing the bond, we are writing the bond, right? You see that non-metal usually comes second. Let's say NaCl, right? So if you are meeting a metal, right, hydrogen is like comes second, right? But if you are meeting hydrogen and chlorine, you see that hydrogen comes first. Hydrogen comes first. That's what I meant. So based on the position of the metals of hydrogen in a binary bond depends on the other species. If the other species is a metal, then it comes second. If it is in this then it's a non-metal, then it comes first. That's like how we illustrate it here. Now let's focus on how to name these substances. So we see metal, we see hydrogen as metal type one. So hydrogen is metal type one because that particular one electron, that's what it has all the time. So hydrogen sees it as a metal type one. If it's an anion, then fine. So now let's say NaH, right? How do we name this binary compound? So we say that the non-metal part, right? We just add IDE at the end. That's what's going to happen. So it's going to be, this is going to be sodium. We are not going to put any oxidation number because it's a metal type 1 here. Sodium is a metal type 1. Sodium hydride. Hydrogen, the base name is hyd, the IDE become hydride, sodium hydride, right? The same thing for calcium. So if you have calcium, CaH2, right? This is what you have. You become calcium hydride. If you are meeting with a metal type 2, CuH, this is copper 1 hydride. Copper 1 hydride. Simple as that, like how we name it. So we follow the same procedure. Okay, so here you calculate the oxidation number, right? So you take hydrogen as -1 in this case. So this is like 1 times X plus 1 times -1 of the hydrogen equals to 0. Then you calculate, have S is equal to +1. That's why we have copper 1 hydride here. So that's it for sodium hydride, right? So sodium hydride, copper hydride, potassium hydride, whatever hydride, right? So that's for hydrogen. When hydrogen is meeting, it's in a bond with metal. When hydrogen is in a bond with metal, that's what happens to it. Now let's talk about when it is in a bond with the other one, the non-metal. So if it's in a bond with non-metal, it acts as the metal part, right? Like how we did it. But you don't calculate oxidation. You don't calculate the oxidation state for the hydrogen. No, you don't do that. So something like H2S. This is hydrogen sulfide. Sorry, sulfide. Sulfide. That's how we do. If it were sodium, you say sodium sulfide. They say hydrogen sulfide. So if you have something like HCl, the HCl that this is hydrogen chloride. Hydrogen chloride. Yes, this is it. So someone will say, what about this one? H2O, the popular one. Is it hydrogen oxide? Is it hydrogen oxide? The name for this is water. The name for this is water. H2O, the name for it is water. Aqua, water. So that's it. So you see H2O, what's the name for it? What the impact name for H2O? Write water. Water is the answer for H2O. But then for these guys, H2S, and then what should I combine again? Hydrogen and bromine, right? So hydrogen and bromine. This hydrogen bromide. Hydrogen bromide. So that's what the behavior of hydrogen. Hydrogen bromide. If it is emitting hydrogen HF, is hydrogen fluoride. Hydrogen fluoride, right? What other thing is there? In exception of some, hydrogen doesn't act as the second guy. There are some compounds that there are exceptions always, like this one, NH3. This ammonia. So the name for this is ammonia. So the name for this is water. So keep this in mind. These are common one that you have to know. The name for this is water, and the name for this is ammonia. Yeah. So keep these things in mind for them. When you meet them, that's how it is. Also, we also have phosphine, pH3. pH3. This is phosphine. So these are the names for these guys, right? The phosphine, ammonia, water, the one we had here. So know their common name. That's the name for them. When they ask you, that's the answer. That's their name. So you need to know them basically. Aside that, the other ones, hydrogen chloride, yeah, based on whatever comes to you. That's it. But then I want to also tell you something that in the next session, we're actually going to start naming of acids. And naming of acids are something that also actually contain hydrogen. They contain hydrogen, all right, but you have to take note that those substances, if you have HCl, for example, this is hydrogen chloride. But then when you put something like this, tell you the state, whatever you put already in bracket, it's the state. So this is hydrogen chloride, right? But you see AQ. AQ means aqueous. Aqueous. Meaning that if it's aqueous, meaning that this HCl is dissolved in water. It is in water. If I put something like the HCl, made that HCl, the liquid form of HCl. If you have HCl, it's liquid, it's a gaseous form of HCl. But if you have HCl aqueous, that's going to be HCl dissolved in water. We call it hydrogen chloride, aqueous hydrogen chloride, right? Aqueous, that's what the name. That's what the name. But when these hydrogen containing substances like are inside are aqueous or they are dissolved in water, we actually have a different name for them. We call them acids. When these hydrogen containing substances that we said are dissolved in water, we call them acids. Hydrogen bromide, this is the name. But when it becomes aqueous, this is now an acid, and we have a way of naming it. In the next session, we'll talk about naming of acids, binary acids, like that. So I want you to know that the name for them, if it is in liquid form, is hydrogen chloride. If it's given from gaseous hydrogen chloride, right, liquid hydrogen chloride. But if it's aqueous, you don't have to call it hydrogen chloride again. The name changed to an acid, and we are going to look at that in the next session, right? Naming of binary acids, right? So that's why we take our time to talk about all the substances. Now we are focusing on hydrogen. And hydrogen, this is how they combine. When it is meeting a metal, it acts as a non-metal. Then when it is a non-metal, it acts as the metal part. Then you look at the naming side that we did earlier. Then we also talk about the state. If the hydrogen containing substance is in aqueous form, then it's an acid. If it's not, then it's just the normal name, hydrogen chloride, hydrogen bromide. And when it becomes aqueous, then it's an acid. And naming of those acids is what we are going to look at in the next session. See you there.